AirMap. An inexpensive, easy-to-use, highly capable mobile air pollution monitor. The first battery-powered solution capable of sensing ozone and particulate matter and geolocating the data without the need for external devices. With the AirMap platform, consumers and researchers can visualize and grab just their data, or look at all of the data collected over many devices, manage your device data in the cloud, or take it offline by making an account. The first step to solving the air pollution crisis is to understand it.
Hi, my name is Nick Tosta, and on behalf of the AirMap team, I'd like to give a brief overview of the AirMap system. There are three main components: the AirMap device, the AirCloud server, and the web front end. The AirMap device can be purchased by individual consumers for use in their neighborhoods, or by scientists, researchers, and municipalities to monitor pollution over a larger area. These devices are intended to be given either placed at fixed locations around a city or given to mobile units such as mail carriers or placed on duck boats, for example. This would allow individual devices to be used as force multipliers, collecting data over a large area as though it were many devices. As any AirMap device collects data, it has a cell module inside, much like a cell phone. This allows all of its data to be transmitted over the cell network to our AirCloud server. This server then processes and aggregates the data in its databases. From there, any device, any internet-connected device, can access the data via the web front end. This allows visualizing data in real time, as well as allowing researchers and scientists to download aggregated data and run their own analytics on it. The AirMap device was entirely custom designed and built by the AirMap team. This includes all of the electronics as well as the mechanical enclosure. Here we see the non-enclosure device, which contains all of the electronics inside the device, except without the mechanical constraints. Here we can see that the MCU is a Raspberry Pi Zero, selected for its low cost and ease of use. We also have a cellular module, which enables our real-time communications and provides geolocation via the GPS module. There is an OLED display for real-time feedback, and our three sensors: the particulate matter sensor, the ozone sensor, and the temperature and humidity sensor. And then, of course, the system is rounded out with signal conditioning, power, the fan circuit, and of course the ADC. All of these components were combined onto our custom printed circuit board, which enables our small, sleek form factor. Now, we'd like to give a demonstration of the entire AirMap system. Here, we see the non-enclosure device as well as a full enclosure device, although right now only the non-enclosure device is collecting data. Also shown here is the AirMap website, which is currently displaying a live feed of all incoming data to the AirCloud server. Now, if we turn our attention to the real-time display on the device, you'll see that we're reading about 4 micrograms per meter cubed of particulate matter. And if you turn your attention to the website, you'll see that our current location is green, indicating a healthy level of pollution. In order to simulate an environment with high levels of pollution, we'll have Chris blow into the sensor. As you can see, this has greatly increased the particulate matter readings on the real-time display. And if we observe the website, we'll see that our current location has darkened, indicating an unhealthier level of pollution. In this way, the entire AirMap system can be seen working together. Any user can access live, accurate pollution data in real time.
Now we're going to walk through a demonstration as to how somebody who just bought their first Air device would begin to use the AirMap visualization platform. We see here this person is creating their login credentials so that they can begin to link their devices to their person. First, they will contact us for an API key. With this, they can begin to register their devices to their login, as well as post data from those devices to the AirCloud platform automatically. Now this user is adding their devices, and they will use that to select the My Air Devices Only feature, where they can see data only coming from their devices. They're first interested in a real-time feedback using the live feature. So this user has their device on campus and they are seeing real-time feedback. They can also use the animate feature to see a time lapse over a couple hours where they were walking around Northeastern's campus. The feedback here is green localized blocks, which indicate a healthy air quality index for the PM 2.5 option that they selected. In addition to this, with simulated data, we can see what this platform may look like if we had many users over the city of Boston. This user is selecting to see aggregated data over all of Boston through a course of a day, and then selecting an animation of that data over the course of the day. We may expect to see areas like Northeastern to have a healthier air quality index, while areas like the Mass Pike Junction with 93 may have a less suitable conditions due to cars constantly driving by. In addition to this, we have also provided a means of exporting this air device data to a format that can be further used for analysis by researchers. And to complement this system, we have also provided a backlog of EPA data dating back to 1980. So we see here the user is selecting to opt for EPA data from 1995 to today and selecting the Kenmore Square EPA monitoring site, where they will see a moving average charts of concentration as well as the ability to export this data to CSV.